Hello guys, in today's video we will create this 3D version of Tetris, which turns out to be quite a challenging game, all the way from scratch. So let's get started. As always, we start with creating a project. Let's call this one 3Tetris. It's gonna be a European project. Let's start by adding the necessary resources. Go to the package manager and go to the Unity registry and look for Cinemachine. Install it and then input system. And now let's also add an asset. We're only going to use one asset for this. I want to have a skybox. We will need that for the reflections. It's not that important, but it will just make the game look nicer. So I got this free HDR skyboxes pack. I think it's a good one. So let's import it. Let's start by setting this skybox. This is the default skybox, and we're gonna change it to this one. Okay, I think this is just fine. What we're now gonna do is create a plane. Let's reset it and change the scale to 2000. So it's gonna be really big, covering all the ground. So let's call it floor, and we're gonna create a material for that. So first let's create a material folder. And then let's add a material to it. Call it matte floor. Now we're gonna use a texture for that. I'm gonna copy that from an old project that I have. So let's just use this one. But you can download your own texture from internet, of course, if you prefer that. So now let's set the texture on the material and the material on the floor. And now actually these wooden parts are a bit too big, so let's use tiling to make them smaller. And now what I want to have is to reflect the sky onto the floor. So we'll have those nice clouds showing up over there, and we can do that by just setting the smoothness and the metallic. Now the floor is almost invisible. Let's just make it a little bit more visible. Something like this is fine. So now we see the floor, but we also see the clouds reflecting on the floor. While we're at it, let's just also change the global volume settings. We don't need bloom for this game, so let's just remove it. We also don't want tone mapping. Vignette could be nice. to create a little bit dark edges. And what I do like is color adjustments to increase the contrast and the saturation to make it a really bright game. Okay, this looks good. The next thing we're going to do is we also want to have the camera circling around the play field of the Tetris game. It will just make it a bit more difficult, and also will show you all the sides of the play field because it's in 3D. So therefore we're gonna create an empty game object, and let's call it camera look at point. That's the point where the camera is going to look. And now we can also add a Cinemachine virtual camera. And that virtual machine camera will look at, well, you guess, the look at point. Let's position the look at point at 6, 9, 6. I'll explain later why this is. Now first let's create our first script. Let's create a script folder. And let's create a script for the camera. We are going to create a reference to the camera look at point, because we're gonna be needing that. Now we're gonna store some things like an angle, so we can use that to circle around the and we also need a camera distance. So we're going to increase that angle by 0.3 times time delta time. So we compensate for the frame rate with the time delta time as usual in the update function. And now we're going to set the position of the camera. We're going to use the camera look at position, but we're going to add the angle to it. So we're going to add the angle to the X and the Z axis with cosine and sine. And we're also gonna use that camera distance, which I'm gonna set to 60. You could also serialize that like this value and then set it from the editor. But I know what value it's gonna be and it's not gonna change. So I'll just keep it at 60. So we're gonna multiply the angle by this value, by the camera distance, and that will make it circle around the camera look at point at a distance of 60. And for the y value, the camera is gonna be a bit higher than the look at point, so it's gonna look down to the look at point. It's gonna be 20 higher. So I think this is it. So let's save it now and let's see if it works. So then we need to attach the script to the camera. And we're gonna attach it to the virtual camera. I can't find it yet, but let's just add it like this. Oh, it's because I made some mistakes. Actually, I didn't make any mistakes, but the assets that we have contain some errors, so that's why Unity won't compile. So this can happen when you add third-party assets. So in this free Skyboxes pack, there are some scripts. We can just delete them because we don't really need them. We can delete all these sample scenes. And now the compile error should be gone. So now we can add the camera script. And we need to set the look at point. And now let's run the game. And you can see that the camera is circling around this area. We see the sun over here, so we might want to set the directional light a bit more from above, like this. So we're gonna create the boundaries of the playfield now. I'm gonna use cubes for that. We could also use a plane. That would be maybe even make more sense. But a cube has the advantage that we can set the scale to fit the cubes that will be inside the Tetris playfield. So I'm gonna set it to these values, and let's just make it very thin, something like this. Let's position this. So this is indicating that our playfield is going to be 12 blocks wide and 12 blocks deep. So we can just copy this this cube. this one over here, and I'll copy another one. And rotate it by 90 degrees. Okay, so now let's set the material. We're going to create material for this as well. Now we're going to copy the material. Okay, this looks good. We only want to close up a little bit. So let's go to the virtual camera and change the field of view. Something like this. Now we need to store this value because we are in play mode, and when we stop then it's gone. So now we need to set it back, and now it's persisted. So this is a basic playing field where the blocks will drop. Let's organize this a little bit. Let's call it boundaries and put everything inside here. Let's first reset the transform. And now we can just fine tune this a little bit. I think it should be a bit higher. Okay, the next thing we're gonna do is create some controls. I want this game to be playable on both computers and mobile phones. So I want to create some buttons. So let's create a few buttons, and it will automatically create a canvas for us. We will import the TMP essentials and the extras. So we have some fonts to work with. By the way, this asset also contains an error at the moment. Apparently Unity changed some things that made this this code break that was there for the assets. But we can just remove that, I think. So it's in the assets, text mesh pro, examples and extras. Here are some scripts. We can just delete them as well and get rid of the error. So now if we take a look at the canvas in 2D mode and press Shift and F, we can find the button over here. I prefer to have a panel in between, so let's create that. Change the background to black, slightly transparent. Put the button on the panel, somewhere over here. So now what we want to have is not a text, but we want to have like arrows that indicates what the what's happening when you press that button. I think there will be something like left and right, So we need 2 buttons over here, and there will also be down and up, but also rotating in different directions. Where with the 2D version of Tetris you will have only need to go left and right, but here you will also need to go up and down to go to the here in this direction, and not only in this direction. So we need to move in 2 directions. So we're going to be needing at least 4 buttons for the movement and another 4 buttons for rotation. And now we're going to create some pictures for them. I'm going to use paint.net for this. This is actually not really part of the tutorial, but I can just show you quickly how you can easily create some pictures yourself. So this program paint.net already has some arrows in it. So I choose an arrow, I choose to fill it, and then I can just create an arrow like this, or I could give it a different background color, something like this. It's just whatever you prefer. I keep the background transparent and I save it as PNG. Then when we open it in Unity, we can still change the background color to anything we like. Let's also put a text in here, because this is the right. On the keyboard that's usually the D. So let's also, just for extra information, let's increase the size of this. So you can press either the button or you can press the D key, and both will make the blocks move to the right. So let's save this as a PNG. Let's create a new folder called images. And let's call this left. I've stored the image, the PNG image, in a folder called images, and I'm gonna set it to a sprite, single sprite. And now we can just replace this text with an image. And you can do this for the other buttons as well. I'll leave that up to you. Okay, I've changed the images a little bit and I added the other images as well. So now we have buttons over here. The next thing we're going to do is create a prefab for the blocks that we want to create, the Tetris blocks. So let's create a new folder called resources. It's important that it's called resources literally, because if you give it this name, Unity will be able to find it as a resource. So we can just first create a 3D cube in our scene. We have a scale of 1, 1, 1, so that's perfect. We're just gonna reset it to the default position, and I think we're already, well, let's add a material first. Let's create some materials for the block. Let's first make a red block. So change the color to red. And we can already see how it will look on the cube. Again, we want to have some metallic look and smoothness, so it reflects. And let's also make it transparent. Okay, I think this will do. So if we have a bunch of these, we'll have some Tetris block that we can use in our game. So now let's make the prefab, put it in resources just by dragging this cube in here, and let's call it PF, prefab cell. So this is one cell of the Tetris block. I call all the cells together the block, and this is just one of the cells that the block consists of. So now that we have this, we can also create some more materials, because we don't want all blocks to be red, of course. We want to have some variation. So let's also make a blue block. And a yellow block. Green block. Pink block. So now we have blue, green, yellow, red, pink. Oh, I think this is enough for now. Let's just delete this one. So this is a colorful range that we will use for the blocks. Next thing we need to do is write a script for this. I've already created the scripts, so we don't need to type them in now. I will just go over the code and show you how it works. And you can either copy it from the repository, my public repository, or you can type it in yourself if you want to have a little bit of practice. So let's also create a game object over here for the scripts, and create a game object called game, because the game script will be in here. You see that the game script requires some things to be set. For example, the materials. So the materials we just created, so we can add them now. But first I will run through the code to show you how it's working. We start by the code, the game script. All the code of the game is in this script. So because we have only a small game, we can put everything in here. Let me run through the code and explain you what every part does. We have, let's make this a little bit bigger. We have a three-dimensional array that contains all the squares in the playfield. So all the squares in here have an X, Y and Z position, and we keep track of them in this array. So here you can see the playfield size. We use a size of 12 and the height of 26 blocks, 26 cells I should say, 26 of these cells. And that's where we store all game objects. And the game objects are just the single cells over here, instantiated with the PF cell, this prefab. We also created an enumeration. We'll have different type of blocks. Over here you can see that the original Tetris game consists of blocks, and they call them like L and O because they resemble a little bit letters of the alphabet. So I've also created a three-dimensional L and O block. So the O block is just a cube consisting of 8 cells, 8 of these cells. So these are the different type of blocks that the game can create now. And I've also defined a class for the block object. A block consists of cells, and it has a block type, and it also has a certain material. So we want every block to have a different material, a different color. And a block also has a position. So if you see the blocks are created over here, and over here you can see that we're creating the cells. So this just gives us 5 different cells together creating letter L. And this is the block I talked about earlier, the O block, consisting of a big cube of 8 different cells. So over here is just the definition of the blocks. And then if we go to the cell, it's also a class. A cell has a parent block because it's a part of a block. It also has a position within the block, and it has a game object attached to it. That's the prefab of the cell. And we can set the position, and if we do so, we also set the game object position, because it's a bit different than the position. This is the X, Y and X, Z values of the within that playfield, and this is the real position. And over here you can see that as soon as we create a cell, we instantiate a prefab of type PF cell, and we can say like this: resources load, because we put them in the resources folder. Otherwise we would have needed to create a reference to a PF cell, which is also not a big deal, but I choose to do it this way. Alright, so let's go back to the main game script. So you can see the block size. This is just the size the maximum size, let's say, of one block. So if you take a look at a cell like this one, we can create multiple cells, and this is then what I call a block. And a block can be 4 high, 4 wide, and 4 deep. So that's the dimensions of a block. So this is defined by the block size. The height allowed, that means there is like a border over here. If we get higher than the height allowed, then it's game over. You're not allowed to have blocks higher than this, the top of this blue square. Okay, so over here some more variables are created. Current block is the block that's currently dropping down. This is of type block. And when we start the game, we first reset the game. We have a code for that because we can call it also when it's game over. And over here I have just some debug stuff. This is not intended to be in the final game, but I've created a layer with a hole. That's just one layer of this, like this, and then completely filled with blocks, with one block missing, and that way I can test the completion of one layer. I will show that later on. So if it's game over, we will press the continue button. You maybe remember that's the enter or escape key. Then it will reset the game. So reset the game, it means setting the game back to level 1, then set the score to 0, and also reset the level. Resetting the level means that we reset the rows that we have completed, the counter for that. The game over panel, of course, should be not visible, and we remove all the existing cells that are there in the still in the game. So we clear the play field, so everything is empty again, and then we can continue. So then the next thing what we do in starting a game is creating a random block, new random block, setting the playing game to true. So, and to create a new random block, we first choose a material. We have that cells materials list that we just filled with 5 different materials. We choose a random index from that, and we set the material to that value. And the block type, we also take one of the block types that we have, a random one of these block types, and then we just create the class of the block, which also creates the cells, and we set the current block to that block. Then to set the score, well, this is very easy. We just set the value, and then also update all the UI elements that have that score inside them. So they need to be added to that reference that I showed earlier on. And the same goes for the level. Then in the update function, if we're not playing the game, we don't need to do anything here. But if we are playing the game, we keep track of the time since the last block dropped. And if it's time to drop a block again, we're dropping a block over here. So we lower the block by one cell. And when lowering the block, we take into account the level. The higher the level, the less time before the block drops again. So finally, on the highest level, level 10, the blocks will drop, fall down very quickly, so that it's more challenging to finish the game. To check for game over, if we want to check for game over, we can just run through all the cells and see if one of the cells is higher than the maximum height allowed. If that is the case, we show the game over panel and we stop playing the game. To check for a row completed, once you have completed a row, this row should drop down and you should have extra points. And once you've completed enough rows, you go to the next level. So this is the check for seeing if we have completed a row. We go over all the different layers, and we see if the layer contains an empty cell. If it does contain an empty cell, then it's not a completed row, so we can just continue. So as soon as we find an empty cell, that means where the playfield is null, it has no game object over there, then we can just break out of this code and also out of this for loop, because then this layer is not completed. But finally, if we've run over all the cells of that layer and it didn't contain any empty cells, then we get to this code where we remove the layer. So removing the layer consists of destroying all the game objects in that layer, and then we need to lower all layers above that one layer. So, and that's what this code is doing. So we're looking at one layer higher than the layer that we just removed, and we put everything in there down by 1, the y-axis down by 1. So then everything drops in that layer and so on until all layers above the layer that we just removed have been lowered by 1 position. Then we set the score. We set the score taking into account the level, and we also increase the rows completed. If you have more than 10 rows completed, the level is finished and we go up a level and we reset the level. Then the function lower block by 1. This is making sure that the block is going down by 1 cell. And if we go down by 1 cell, we also check if it's colliding with something. And if it's not, then we just continue to fall down. But if it is colliding with something, then it should stick at that spot. And we are checking if it's game over or not, because we just have a new block that's not moving anymore but is stuck somewhere, either on the floor or on another block. And we also add these the cells of that block of the current block to the game field, to the play field, because it's only contained in current block at the moment, but all the separate cells, they should be referred to somewhere in the play field, and once that's done they can later be removed because we have references to them in that play field. So after we've done that, we can create a new block, and the current block will be replaced. We'll have new cells, and these cells just stay here on the play field. Then for the collision check, we can input a number of cells, and we just check if these cells are outside of the play field. Then there is collision. And also when they are overlapping with some other cell, because if the play field is not null at this spot, then it's overlapping with something, so then it's a collision. So either you collide with the block or with the boundaries of the play field. If it would be here, it would be a collision because it's colliding with the other block, and the game field is not null at that point. And if it's over here, it's also counting as a collision because it's outside of the boundaries of the play field. In both cases, we need to do the same thing. So we need to make sure we can't get into that position. That's why we check it before. So if the collision check is positive and we are colliding, then we won't even go there. We won't change the position, but we will do some stuff with the block at its current position. Then we got the functions, the on left, on right, and on forward to make the movement possible. If you take a look at the game inputs, you can see this name is left, right. If you match exactly that left, right, and you put on before it, then this method will get called when you push this key, the A key. So because this game script is attached to the same input as the game inputs, actually we still need to do that, so let's do that now. Let's add a component, play input, and then we can put the action map over here. So now, because this action map is in the same game object as the game script, as soon as this action is performed, like left, it will automatically call the public methods on left, on right, and so on back, on rotate, axis, and so on. So this code is triggered like that, but we also need to attach it to these buttons. So if you take a look at this button, it's the left button, so we need to connect that to the on left. So we add an event over here, and we add an event of the scene. Go to the game object, and the game object has the game script, and here we have these public methods that we can refer to over here. So we can refer to the on left. So now when you click this button, on click, this code is also executed. So it's executed by either clicking on the button or by pressing the A key. So that's why we made them public. If you only want to use the game inputs like this, you don't need to make them public. You can make them private, and they even will be called then. But for this part, for the on-click methods, they need to be public, otherwise they won't show up over here. So these public functions, on left, on right, etc., they are connected to the buttons and also to the game input, so to the keys. So if you press either the A key or you hit the button, this code will be executed. Then we will check if the block is colliding, if it would be colliding if we move it one cell to the left. The collision check over here, you see that we are just checking if the playfield is null at that point. If it's null, then it's not colliding. If it contains a game object, then it's a collision. And also when it's outside of the playfield, that also counts as a collision. So before we do the collision check, we don't do the collision check on the block itself, on the block object, but we convert the block object to a list of positions where the cells are. So if we take a look at the game field again, you can see a block here. This is actually an L block consisting of 4 cells. And we don't use the block, but we use the cell positions in the collision check, because for the rotated block, that also needs to be collision checked. We need to rotate the object, and if we do that with the real block, then it would have already been rotated, and we needed to rotate it back, or we needed to make a copy if we want to use that for collision check. So this is just for the directions. We check for the collision. If there's no collision, we can move in that direction. Then we have the drop function. The drop function is just a while loop that's just lowering the block all the time until we hit another block or the floor, and that will make the block fall down immediately. Then we have this function where we convert the block to the position list. So we create a position list and we take the block, it's always the current block reference, and we take all the cells and we add them to the position list. And we also can input an offset with that. And we also have the same function, but where we will rotate the object first, and that's the one why we need the position list instead of the block. So here we rotate the current block, and then we add that rotated positions to the position list, and then we check if there is a collision for that. So that's when you are pressing the rotation buttons. So if you press the buttons like these ones, then this whole block starts to rotate, and we need to check if that rotated block is fitting into the position that it wants to be in. If not, then we don't rotate the block. We don't allow the rotation. So over here you see those rotation functions. It depends on which axis we rotate on, but rotation just means actually swapping the axis of the Z and the X, for example. So if you take a look at the block, if you would want to rotate that block, actually this whole block, but let's for example rotate this cube, this cell, then hang on, let's first make this like a block. So imagine that this is a block that we want to rotate. If we want to rotate that ourselves by code without using the rotate functions of Unity, then we could just swap the X and the Y axis, because these X positions, if you rotate it by this, will become the Y positions on that axis after rotation. And that's exactly what we're doing here to rotate the block. So this function rotate is if possible is called on all the rotation buttons. You can see it over here. Then we're rotating on this axis. We check if it's possible with the collision check again, which works on the position list. And if it's possible, then we rotate all the cells. When it's game over, we want to show a panel with some text. So let's create that now. Something like this. Let's make the background dark. Actually, let's make it a lot darker. Create some text like game over. Okay, something like this, and let's add a text. Something like your final score is let's call this text score. And now for during the game, let's add some nice way to show the score in the game. Let's go to the camera, and over here we will add a canvas. On this canvas, let's add some text for the score. And let's add one for the level as well. Because they are now child of the game, of the main camera, these will rotate along with the camera. But we need to make this a world space canvas. Okay, so now should put it in the right position on the camera view. So we can see the camera over here, and let's call this level. Let's just disable this panel for now, and let's move these so they come into view of the camera. Okay, you can see now that we have the score and the level displayed on the screen. Okay, so now we will do something funny. We will add a 3D cube to the main camera. Let's call this a score cube. We need to position it in the right position, just somewhere near the score itself. Let's put it behind the score, and let's change the shape a little bit. Something like this. I've got a marble texture over here. let's use it to create a material. Let's call it mat score cube. Okay, so now what we can do is create a script to make that that cube rotate. That's very easy. What we just want to do is be able to set the rotation speed. So serialize field vector 3 rotation speed, and let's set it by default to it will rotate on the y-axis. And in the update we will then perform a rotation. Okay, I think this is sufficient. We can drop that onto the cube. And then it should rotate. So let's see if it works. Yeah, so now we have a rotating cube over here. We need to fine tune it a little bit, make it a bit more into position. But then we can also create a cube over here, and we can display the score on those cubes. In order to display a text onto a cube, we also need to create a canvas. So we're going to create a canvas on this cube. And we're going to set it to world space as well. Now we can create some text on it. You can see that requires some fine-tuning, but we can get the text to display on that cube like this. Also make sure we don't cast shadows of the score object. So after a bit of fine-tuning, I think this is nice. So let's copy this and call this level cube, because we're going to do the same for the level. Let's move this cube down to the level position. And we're going to display the level like this, I think. So we can offset it to the center. Let's use a bit of different material for this one. Maybe change the color like this. Okay, that looks good. So now we can just add all these score elements on the cube onto the script. So in a script we made a list for the score text, and if we add all these, actually there is another method you can use for that. So let's just remove these. I think we can just drag them in. Let's lock this panel for now and drag all these score text objects in here. And the same for the level texts. And also on the game over panel, there is a score element, so we can add that as to the game script as well. We also need to set the reference to the game over panel. Okay, so we've set all the references for the game over panel and for the score texts and for the materials that we want to use. But in the code we also referred to game objects with a tag called cell. If we want to reset the level, we just remove all the game objects from the scene that have the cell tag on them. So we need to set this cell tag on this cell. So we need to add a tag over here, call it cell, just like this, and then we can set it like this. So now if we run the game, it should be working. you can see that this is the current block that's falling down. It's a 3-dimensional C block, and we see that the score is displayed over here. We also have 2 of those layers that are already filled, except for one position where there is a small hole. We can use that to test the game. So if we use a block like this one, we can just rotate it and put it in that hole position, and you will see that then it will start to drop down. It's actually a bit difficult with the controls to get it to the proper position. So this is actually quite a difficult game to play at the moment. What we could do to make it more easy is there you go, now it's lowering, and because we lowered that layer we got a score of 100, and if you do that 10 times then the level will go up. So we can also test if the game over works. If we just keep adding blocks, you'll see that it has reached the border, and then it's just game over here with your final score displayed. Some small things have changed. The set score, I've also put it over here. So every time the block is lowered, we also increase the score by 1. It's just to make the score a bit more. And also the create layer with hole debug function has now random material put to it, so that if you run the game you will see a random colored layers over here. So you could use those layers just to make it also a bit more challenging, that you've already have some layers and you need to remove them, and you can use them for debug purposes, but you can also leave them out. Okay, that's it. We got ourselves a basic working game. You can extend it yourself by adding sound effects or showing which block will be next. I'll leave that all up to you, and have fun, and see you in the next video.